Good morning to everybody. My topic is IOL power selection using artificial intelligence. Purpose of this IC is to compare the accuracy of widely used IOL power calculation formula, including the artificial intelligence based formula. As you know, the artificial intelligence based formula are Hill, RBF, LADA Super, and the Kane. Regression formula most recently is Barrett, Oleson, and EVO. We have developed a lot of improvement in our expensive machines, and there are multiple formulas, but these old formulas are regression formula. It is all formulas are not very accurate, so no human can ever write a single formula that take account of every adjustment. So that's why the biometry, till now we use the decision tree to devise which formula we use for a particular cases. This is a cumbersome intuition and needs a lot of experience. This intuition is mainly due to inaccurate calculation of expected lens position. But how can we convert this intuition into the approach that is easily available and useful to less experienced surgeon? How to close to the perfect IOL power? We have Barrett formula. This is again the regression formula, but here the expected lens position is calculated very accurately, but how it is calculated it is not known. Now another is the Oleson formula. It is also the regression formula, but is a new concept of ray tracing assisted intraocular lens power calculation. Here is the concept of C constant, which is developed as a simple method of predicting the post-operative position of intraocular lens from the pre-operative dimension of and position of the crystalline lens. Here again, it eliminates the expected lens position with K and artificial axial length and white to white. So there is no guessing because it is not related to the expected lens position. So it gives a very good result. And EVO also, it is also the regression formula. It also gives, it is based on the theory of emmetropization that generates the emmetropia factor for each eye, taking into account of optical dimension of the eye. Now, come to the artificial intelligence formula. To get the more accurate result, we have artificial intelligence calculation with two main approaches. First, using a direct artificial intelligence approach of pattern recognition. In a Hill RBF formula is based on this. Using on the sweet spots of multiple formula is another issue. Here we created 3D surface from the big data calculated from the sweet spots of multiple formula. And what is sweet spot? It is a place where we get the maximum correct response for a given amount of input. Because for a formula, not all the ranges of input gives the equally maximum correct response. So after creating the 3D surfaces, we enter the data and perfect results were obtained by using the artificial intelligence pattern recognition within the big data in LADA super formula. When we upload the data of a patient, artificial intelligence based formula finds a distinct pattern in apparently random clouds of data points already created by a large number of cases based on the pattern recognition of artificial intelligence. Thus, it is a purely data-driven IOL power calculation approach, and therefore it is free from the limitation of expected lens position and also free from the limitation inherent to the standard formula. These are adaptive, dynamic learning process and continuously becoming better and better. Here again, here it is important that here we do not use the expected lens position in the formula. So it is very accurate. It is based on the deep learning. It has already been discussed. Now, Hill RBF has, we have axial length, K reading, ACD and CCT with white to white, lens thickness, gender and ethnicity. The limitations are again they are inbound. The prediction value is reliable, and in prediction value is highly probability that is within 0.5 is the target outcome. Outbound, there is a limitation is called the outbound. The outbound data showing the prediction value may not match the target outcome within 0.5 and not enough data is validated. LADA super formula, as we said, it is creating the LADA super surfaces. In the X, this IOL power is shown in the Z axis and X and axial length, and the corneal power is in X and Y axis. Now, Lada super formula is created by using the four formulas, that is Hofstad Q, Holiday 1, Holiday 2, 1, and with Wang Chong, Wang coefficient axial length adjustment, and Hegges, but not the Barrett. Here, the section of the sweet spots of each formula based on the axial length is shown in this first figure, and second figure, all are connected, and the last the section is amalgamated to a super surfaces that is called Lada super surfaces. It is the interface of Lada super surfaces. As soon as we enter the data in the interface, we get the correct value, and also there is a three-dimensional graph. The surgeon knows instantly if he is handling typical or is unusual eye. It is better than the Barrett super formula. Here we compare the super surfaces of both Leda super and the Barrett's universal formula. Here the blue mark area are they are over it shows the identical results, and the red area gives the not very accurate result in the Barrett universal formula. But for the Leda super formula, it gives extremely good result. Now, another artificial intelligence-based formula is the Keynes. A required parameter are axial length, ACD, and k-value, gender, and A constant. Accurate, and it gives a very accurate results. Now, to verify, we have gone through the retrospective studies in which your data is collected. Here again, the mean numerical error is very low in the artificial intelligence-based formula. The mean absolute error also, the Hill RBF and Leda Super, they are all artificial intelligence based formula. They have the minimum error. And sensitivity of the formula prediction of 0.25, 0.5 and 1 and 2 gives the maximum result within 0.5 diopter of spherical equivalent. This is the same thing as for extreme eyes again. The artificial intelligence based formula is better than the other formula because mean absolute error is smallest in these formulas. Now, for the toric calculation, we have Lada super and Keynes formula, that is artificial intelligence based formula for the spherical part, and the Barrett toric calculator for the cylinder part. If we combine both, then we gives a very good result. For LASIK, post-LASIK calculation, there is no artificial intelligence based formula till now. This is a recent study by the Cheng et al. In the Journal of Refractive Surgery. Here again it shows the Keynes formula and other artificial intelligence formula is better, and especially the regression formula, the newer one are equally comparable. So to conclude, the artificial intelligence formula is a single answer for any IOL calculation query. It is totally data-driven artificial intelligence formula pattern recognition without estimation of expected lens position. Formula should be free from the limitation of lens position estimation. Though Barrett formula is very commonly used, here the calculation of expected lens position is inbuilt and very accurate, but it is important to use newer formula that Oleson, Keynes, Hill RBF and Lada Super. Artificial formula is continuously evolving, and its accuracy is very high. It is more than 90%. So artificial formula being the game changer and is the grandmaster of biometry. Thank you. Thank you for your attention.